So thanks for the lovely introduction. And as mentioned today, I'll be talking about agentic RAG with graphs. As was mentioned, I work, okay, not in the slide, but I work with Neo4j for like 7 years, and I write a lot of blog posts. So even though the presentation will be mostly theoretical, you can then go on my Medium or GitHub and you have basically all the code that if you want to play around and test these things on your own. So let's start with what is not an agentic RAG flow, right? So most RAG pipelines you'll see today are kind of predetermined. So you ask a question, you do like a vector similarity search, you get your similar documents, you pass them to the LLM, and you get your final answer, right? So this is not an agentic workflow because the flow is predetermined. So what is like an agentic RAG, right? So there's like, if you ask 5 people, you'll get like 15 different definitions. But I think like what determines an agent or the agentic flow is that the agent has some sort of influence about the next steps it will take, right? And for that to happen, basically an LLM needs to reason what should the next steps be, and then you also need to give it the option to act upon its planning, right? So this is taken from the React paper, which is actually from 2022, which is 2 years ago, which in LLM world is like 20 years ago. So it's interesting that this framework was already developed before we had like GPT 3.5 or GPT-4. And like last year or so, like a year and a half ago, I don't know if you remember, but there was like a big boom with GPT 3.5, I think. There was like a baby AGI where you had like autonomous agents and you gave it a task and then the agent created like a task queue. Oh, it's actually GPT-4, it says in the slide. And the agent creates a task queue and then you had like execution agents that would go and execute those tasks, and then like the agent could prioritize tasks or remove tasks from the task queue, and it was like really exciting. But I think it was a bit too early, at least for autonomous agents. So there's like a huge potential if you have like an AI system that can reason and act. But the problem was that it just wasn't good enough, right? So it got stuck in loops or like did some unexpected things. But what it did was it burned a lot of tokens, right? So it was costly experiment, but it was kind of hype, but not really production ready. But what it showed us basically that there's a need like for agents and frameworks, and a couple months later, OpenAI introduced like tools, right? So now, basically, most LLMs have the ability to decide if they want to use any of the available tools and execute them, right? So like OpenAI, Gemini, Anthropic, I think as well. You have also Llama 3.2 also has tools that you can give to an LLM, and then the LLM decides if it want to use one of the available tools or not, right? So that was like one step towards having the LLMs act as agents by giving them the ability to act or use tools. And the other, which is kind of ongoing, is that with the providers are improving the reasoning of LLMs as much as possible. So the last kind of hype thing that happened was the OpenAI O1, I think it's pronounced O1 model, where we had basically some hacks at inference time to improve the reasoning abilities of an LLM. But it kind of just shows that like the industry kind of moved towards improving the reasoning of LLMs, but also improving the acting right with the tools. So what does this has to do with knowledge graphs? So basically, knowledge graphs the flexible representation of data. Mostly what you'll see is like knowledge graphs represent entities, which are bubbles or circles here. And these entities can be like real world entities, like people, teams, organizations, or it could be like digital entities like microservices, dependencies, or tasks. And the nice thing about knowledge graphs, in my opinion, is that they're very flexible and nice way to represent both structured data, like teams of people and like who maintains which microservices, but they also can be combined to represent unstructured data, right? Because a lot of information is unstructured, like PDFs or text documents, and the knowledge graph gives you the ability to represent both of these types of information in a single database, right? And because you have this ability to represent rich and maybe flexible data in a single data storage, what you can do is then put an LLM agent in front of it and have it interact with that information, right? So it can retrieve information from the knowledge graph, but it doesn't have to be just one-way flow. It can also store the information from the user interactions, right? So for example, what you would call like short-term or long-term memory, where agent kind of decides some things about a user are interesting, and I'm going to store that information in a knowledge graph. And at first, we were all very excited. So how do you give basically the most freedom to an LLM agent? It's kind of, you can allow it to generate database queries, right? So Neo4j is a graph database, and graph databases mostly use Cypher query language. So that's why when an LLM is generating a Cypher statement based on the user input, we call that text to Cypher, similar as when if like you had a SQL database, people call that text to SQL, right? And that was like, in the beginning, we were all very excited because it's very flexible and it gives like a great deal of autonomy to an LLM, because if it can generate the database query, basically it has the flexibility to do a lot of different types of information retrieval, right? So it can count things, it can filter things, it can do like complex multi-hop queries, whatever, right? But as it turned out is that while generating database queries works like for demos and for like simple schemas with like educated users, what's in the database, it doesn't really work in production because there's like a whole lot of problems to go, and like LLMs aren't there yet in the reasoning capabilities of how to translate like a user question to a database query, right? Even for like text to SQL, which has a lot more data sets and information, it's still mostly too early to have like the LLM be as autonomous and just generate database queries. So what's the solution if you can't have like text to SQL or text to Cypher? Well, the solution is to define like a predefined toolkit. So instead of having directly generating database queries and fetching information using those queries, you introduce an intermediate toolkit. Remember before I told you that LLMs now have tools that they can use. So basically you define a couple of tools based on the business logic required so that the LLM can use those tools to interact with the database. And in this case, what you do is you take away the complexity of generating database queries from an LLM and you put it into a toolkit where you have a couple of predefined flows, and it can be either like static database queries that uses templates, or it could also be like dynamic database query generation based on some input parameters, but it's not, basically the LLM doesn't have complete control over what is what types of queries are generated. LLM just has control over the input parameters to the tools, and then the tool under the hood generates the cipher statement. And this has like a benefit of having more robust tools and also more predictable information. And you also can rely on that information because you know that a subject matter expert came up with the required database queries that retrieve specific information. So there, like here, I have like a couple of samples. So you could have like a movie agent where the user asks a question, and then the agent decides whether should I just find some information about movies. Like if you ask which movies did Tom Hanks appeared in, you can use like the information tool. Or if you wanna recommend movies, right? You can say, find me good comedy that's similar to, I don't know, Ice Age, right? And then you could use the recommendation tool. And like, since these two flows are different, right? They're split into different tools. And here in this example, we also have a tool that can store movie preferences back to knowledge graph. So if you kind of recommend, okay, you want to watch the new, I don't know, Fast and Furious, and then the user says, I already watched that movie, you can store that information back to the knowledge graph so that you can use it to update recommendations, but also to know that you should never recommend that movie again back to the user. And just here, I just have like a simple example of one tool, right? So a tool is nothing crazy. It's basically just one, in this example, Python function. But the nice thing about it is that instead of like text to cipher, text to SQL, where you only have one database query generated based on the input question, the tool can be much more involved, right? And it can you can instruct the LLM basically to have like specific processes to map values from user questions to database. Like for example, if you say which movie did Tom Hanks appear in, like you have to kind of find that value in the database, and there are like different ways to go about it. Or like if the question is too ambiguous, you can basically instruct the LLM to ask follow-up questions. So the nice thing about tools is that it can have much more involved logic, and you can guide the LLM to perform much better as a chatbot, right? And this approach is applicable to many domains. Like before we had a movie domain, and now we have like a biomedical domain, but it's the idea is the same. You have an LLM agent with a couple of tools available that it can interact with the knowledge graph in a predetermined way. Now, the downside is obviously you need some upfront work, right? Because you need to define those tools. But the upside is that you will have much more reliable and consistent outputs from the database and consequently from the LLM agent, and that improves the accuracy of answers given by a chatbot. And here I just have like the agent flow can be more involved, right? Because in the beginning I said some flows are predetermined, and then Agentic kind of decides which steps it should take. But like in practice, you can have a combination of some predefined steps. Like here in this example, we have like 3 predefined steps, and then based upon the information available at this step, the LLM decides which of the next steps it should take. And when it decides it has enough information to answer the question, it just goes to the, here in this example, answer reasoning step, and then the final answer is given back to the user. So the main idea that I want you to take is that at the moment, like while full autonomous agents are really cool, we aren't yet at the phase or stage where you want to have full autonomous agents in production. They're nice for demos, but for production, you want to constrain them and give them predefined tools instead of just allowing them to do whatever they want. And another thing that I find really not interesting, but really vital is that anytime you can move any complexity away from the LLM and describe it as code, you definitely want to do that, right? Because the less complexity the LLM deals with, the better the results will be. So this is a quick 15-minute introduction to agents on knowledge graphs. And if you want to learn more, here's the blocks and the code supporting the blocks.